right, guys, so today we're going to do some very simple polar graphs. And so we're going to do it all without a calculator. And so we're going to have to put our thinking shoes on and figure it out. So how would we graph r is equal to 3? Think about what that means. That means the theta can be anything, but the radius would have to be 3. So theta could be 0, and I'd get that point. Theta could be pi over 6, pi over 3, and so on and so on. So what is r equals 3 going to be a graph of? And of course you say it will be a circle with a radius of 3, centered at the origin, and a radius of 3. Well, that's pretty easy. Would it be any different if it said r equals -3? Nope. It would be the exact same graph, because your thetas could be, you would say maybe pi over 6, but it would go backwards and it would graph this point. So even if it said r equals -3, you would have the exact same graph. Well, in the same way, let's think about theta equals pi over 4. Think about what that means. That means theta could be pi over 4, but the r could be anything. So r could be 0, which would be at the pole. I could have a radius of 1, 2, 3, 4, and I would have a line or a ray that goes like this. Now, is that my final answer? No, because if r was negative, I'd come out this way. And so the graph of theta equals pi over 4 would look like that. Obviously, are there other things that would give you that graph in polar? Yeah. Hopefully you would say, if I said, give me another name of that, theta equals 5 pi over 4 would graph the exact same line. Good. Okay. Again, we're not doing a polar. If you want to have fun on you're bored on a Friday night and want to say, hey, let me check out some more polar graphs, then you could do this. There's actually some pretty cool things you could get, but I'm going to do this all without a calculator because we're going to use our noggin and what we did yesterday. If that said r sine theta equals 2, r sine theta, that sounds familiar. R sine theta is y. So if I say graph y equals 2, boom shakalaka, we done. There we go. So if it says r sine theta equals -3, oh, nothing but a thing. I would get that. Perfection. That's a line. It's just ugly. Very good, very good. Now what about r cosine theta? Oh, you know that. That's going to be x equals 1. So you come to 1 and you just draw a vertical line like so. R cosine theta equals -4. There's the rectangular form. 1, 2, 3, 4. And you're drawing this. Too easy, too easy. The last one we're going to do looks like this. So be very careful, because notice that the sine of theta is on the right side. And please know, I could get tricky. Up here, I could write r equals 2 over sine theta. Well, wouldn't that be, if I rearranged it and I popped the sign over, it would look like that. So please know, when I say sine's on the right-hand side, I don't want to say it that way, because I could write this equation with sine on the right-hand side, and it's certainly not, this one's going to be a line. So when I say the sine is over here, notice if I moved it to the left, it wouldn't say r sine theta, it would say r divided by sine theta, which certainly isn't y. So this one, I'm going to do a T-chart really, really fast, and I'm going to make it like really fast. Let's do the easy ones. Let's do, if I put in, and I'm just going to do it in my head, I'm not even going to write it out. If I put in theta being 0, the sine of 0 is 0, right? So r would be 0. That would just be here. If if I had pi over 2, let's think about this. I might write it out. Now, what's weird with an r theta is you normally put in the thetas and you then get the r's. So with theta being 0, we got r to be 0. With pi over 2, the sine of pi over 2 is 1. We got 4, which where would that point be? Well, by our knowledge of points, pi over 2, 4 would be 1, 2, 3, 4, would be up here. Pi, these points, are they giving me anything different? Because that would be 0, which is here. And then this one, think about it, 3 pi over 2. The sine of 3 pi over 2 is -1. That would give me -4. But where would that graph? That would graph actually at this same point, would it not? So that's all that those points give me. And you can believe me, I wouldn't lead you astray. If I plotted more points like pi over 6, let me just do, because pi over 6 would be an easy one. Let me do one more. Let me do pi over, well, I didn't mean to do that. Let me do pi over 6. I'm kind of running out of room. What is the sine of pi over 6? That is 1/2. 1/2 times 4, that's 2. So 2 pi over 6 is about there. So just trust me, if you would. If I kept plotting points and did more, what I would actually get, I would get a circle as well, but notice that the circle is not centered at the pole anymore, okay? It is not centered at the pole. If I did the same thing with cosine of theta, would you have a guess as to where that one is? Well, if I did cosine of theta, 1, 2, 3, 4, if you did a similar t-chart, and I put in those same values, what happens is that this one will be 4 and -4, which would graph, oh, I did that backwards. No, that's right. Yeah, 4 and -4, and these two would be my zeros, and I would get those 2 points. If I did more points, you would get a circle that's like this. I never can draw circles very well. So here's the deal. Both of these are circles, yes, but notice the diameter is 4, okay? Is this number here, and the diameter is 4, not the radius like the other circle was, okay? The other thing I want to point out is sine versus cosine. How can you memorize that? Well, sine is always with y, and cosine is always with x. So do you notice that the cosine circle is symmetric with the x-axis? Do you see how you have the x-axis kind of cuts it in half, whereas the sine, the y-axis, is its line of symmetry. Now, what do you think? What do you think would happen if I had -5 sine of theta? Well, I would hope you would say, sine, I know that's of the form of a circle. It's going to have a radius of 5. It's going to be symmetric to the y-axis, but because the r is negative, it's going to be down there. And this would be down here at -5. Okay. Likewise, I bet you could guess if r equals -2 cosine theta, it's just going to end up being on the left side. So here's what I was talking about for giggles and fun is you get a lot of cool things. You can do a lot of cool things in polar. We just don't have time. If you go on to BC Calculus, you will be doing all sorts of things, finding the arc length of these things. They're called roses. They're called limicons. They're cardioids, all sorts of things. Finding the area in between these things. So there's big fun ahead if you go on to BC or take an upper level math class in college. For our purposes, these simple graphs are going to be very simple, hence the word. So let's get it back together. This is kind of your memorized sheet for the quiz. R equals A. What is that? That is a circle. You could probably figure this out already and know this. It's a circle that looks like this, where this is A. Theta equals, that is a line, so make sure you have it with arrows. Obviously, it could be in any two quadrants, 1 and 3, 2 and 4. Make sure that you do draw a line. Don't draw a ray, and make sure you go through the pole. Remember, the pole is the 0, 0. With these two, when it's r sine theta or r cosine theta, think about what its rectangular would be. This would be y equals a, so this is going to be a horizontal line at a. So if a is positive, of course, it's going to be up there. If a is negative, it would be below. Our cosine theta is x equals a. That is a vertical line. Again, positive over here, negative on the left. And lastly, our final little ones, these are also going to be circles, but they're going to have a diameter of A. And remember that with cosine, it's going to be, the x-axis is its line of symmetry. So it's going to look like this, where this is over at A. And if it's sine, it's going to look like this, where this is up at A. And remember, if you had negatives, then it would be to the bottom and the left. Okay? So that's kind of your memorized sheet. I think that's super easy. Hence, you should do great on the quiz. All right. Peace out.